Look at the rule for multiplying the conjugates rule. A plus b times a minus b. What happens to the middle term when you are multiplying conjugates? Katie? They cancel out, and what you're left with is squaring the first term minus squaring the second term. And then we also learned a rule for squaring a binomial, such that you square the first term, square the last term, and to get the middle term of the trinomial, you multiply them together and double it. And it works the same whether or not there's a minus or a plus. So now imagine going backwards. Now, first off, if you only have two terms, okay? If you have two terms, you have two options. Okay? Option number one, you might want to write this down, is that the only thing you can do is take the greatest common factor. Option number two is if it's this type of two-term binomial, then you could factor it like a difference of squares. And we'll call this a difference of squares. And the way you would work backwards for a difference of squares is that you would take the square root of each of them. Make one a minus, make one a plus, so that it goes back to this form. Now, similarly, when you see a problem like number one, if it is a perfect square trinomial, then the following must be true. So for perfect square trinomials, this has to work first. You take the square root of a, you take the square root of b, I mean c. Cancel that. Take the square root of a, take the square root of c, multiply them together and double what you get. Check to see if that equals b. That's how you can tell whether or not you could use the rule. So I'm going to write this kind of small next to my number one. Megan, what's the square root of the a term? Number one. So the a term, yes, exactly. The square root of 9 is 3. Remember, you guys, the form for trinomials is ax squared plus bx plus c. Good. Ingrid, what's the square root of c? 4. When you double 3 times 4, what do you get? 24. Does this fit the model for a perfect square trinomial? Yes. So I can just say that the answer is 3x plus 4 quantity squared. Aaron? The 2 is in the rule. Remember, to get a perfect square trinomial, you multiply them together and double it. So for me to see if it works, I have to square root a, square root c, and double it and see if it works out to be the b term. Yes?
How come 3 has an x but 4 doesn't?
Because 3x times 3x gives you 9x squared, and 4 times 4 gives you 16. Good. Griff, any questions? All right. So now number 2 has two terms. Well, you can't take a greatest common factor, so hopefully it meets the requirements for a difference of squares. The way you see if it meets the requirement is each term must be a perfect square, and there must be a minus sign. Does it meet that requirement? Mm-hmm. Yes. So take the square root of each term, 7x, 7x. Take the square root of the second one. 1 square root of 1 is 1. Make one a minus, make one a plus. If you were to refoil that, you would end up with what we had in number 2. We're just taking the rules and doing them backwards. Oh, so when you see ones like this, it's much easier. In fact, you could factor the trinomial just like we did yesterday and on Friday. But for a problem like number 2, you have to remember the difference of squares, or the conjugates rule, to be able to factor it. All right, moving on. Let's first test it. Does the square root of 16, what is that? 4. What's the square root of 9? When you Double that? What does that equal? Does 24 equal 72?
No.
No. So this is not a perfect square trinomial. All right. So now it's a regular one to go ahead and factor. Let's see if we can factor it. So for 9 we have 9 and 1, 3 and 3. For 16 we have 16 and 1, 2 and 8, 4 and 4. Go. See if you can do it.